Here is an outline of what we will cover in this session. First, we will discuss how contract packages and versioning work on Casper. Next, we will go through the contract versioning flow, which includes creating a new contract as part of a package, adding a new version of the contract, and then going through the steps to build, install, and verify the contract behavior. We will also cover different ways to call a versioned contract. We will look at creating a locked contract for use cases where we don't want to version a contract. We will cover the function that can disable a contract version as part of a package. Like any software versioning, you can think of NPM versions, for example. When you upgrade a contract on Casper, you simply add a new version to a contract package. The versioning process is additive rather than an in-place replacement of an existing contract. The contract package is like a container for different versions, with functionality that can differ slightly or significantly as you wish. The package is created when you install the contract on the chain with the new contract function. When you create a contract, you can specify whether a contract is immutable with the new locked contract function. Otherwise, contracts are upgradable by default. You can also deprecate old versions or prevent further upgrades. You can also set permissions around who can perform contract upgrades using the account model. New contract and new locked contract are convenience methods that prevent contract authors from having to know the machinery or to type out the multi-step process with a particular order. You can see what these methods do by looking at the contract API implementation in GitHub. Generally, we recommend using these functions for convenience and consistency. In general, you would create an installer deploy to put the package and first contract version on chain. After some time, you may have reasons to upgrade your contract package. Your reasons may be a bug fix or a new feature. You would create an upgrader deploy that adds a second version to the contract package to address your reasons for the upgrade. In this video, we are going to demonstrate the example workflow for upgrading a contract package. We will work with the contract we have already installed called the counter contract. Here we want to add a new version of the same contract with a new entry point. To do this, we will use the add contract version function. Then we will build a new contract and generate the corresponding WASM, after which we will send a deploy to install the contract on the network. In step 1, we will create the new unlocked contract using the new contract function. Under the hood, the execution engine creates a contract package, which is the container for the contract. That container can be versioned. To access the contract later, we need to specify a package name and an access uref. If you want to upgrade a contract, storing the access uref is mandatory. This is a custom string of your own choosing that you will later reference when interacting with the package. By providing a name for the access uref, you are telling the helper method new contract that you want to put the access uref in your named keys under the name you mentioned. The access uref will allow you to upgrade the contract later. Then we see the contract key is the hash of the contract. We also store the latest version under contract version key in global state. Here are a few things to remember. We are versioning the contract package, not the contract. The contract is always at a set version, and it is the package that specifies the contract version that we want to use. Also, the WASM file name of the new contract could differ from the old one. After sending the deploy to the network, the contract package hash connects the different contract versions. To add a new contract version in the package, we will invoke the add contract version function and pass in the contract package hash, the entry points, and the named keys. Here are a few things to note. The new contract version carries on named keys from the previous version. If you specify a new set of named keys, they will be combined with the old named keys in the new version. If the old and new versions use the same named keys, then the newer values for these keys would take effect. You will need to manage the contract versioning, considering clients that may use older versions. You can use the call version contract with a version number to pin your client contract to a specific version. You can also call a contract using call version contract and version none, which uses the newest version of the contract. Next, let's use the make prepare and build contract to prepare and build the newly added contract. Once we are ready, we could install the contract on the network via a deploy and verify the deploy status. You can monitor the event stream to see when your deploy is accepted. Next, we would verify the behavior of the new contract. The Casper unit testing framework can help with writing these unit tests. Here are a few details about calling your contract. You can call a version contract using Rust code, using the call version contract API function. If you want to use the command line Rust client, you can call a version contract using the Casper client and specify the package hash or the package name, as well as the contract version. If you don't specify a version, the latest version will be invoked by default. If you wish, you can create a locked contract package from the start using the new locked contract function. Apply the contract entry points and named keys when you call the function. You can also specify a hash name and a uref name that will be placed in the context named keys. You do not need to save the version number returned since it will always be equal to 1. Remember that this contract can never be upgraded and this decision is irreversible. If you have created a version contract package, but you want to disable certain contract versions, you can. This is different than lock contracts, which cannot be versioned from the start. You can disable the indicated contract version of the indicated package by using the disable contract version function. Disabled contract versions can no longer be executed. The contract maintenance process is generally covered through the contract upgrade or versioning process. Only major version changes in the Casper node software would require specific contract maintenance, because a node version will have a one-to-one mapping to the contract version. We anticipate version changes with Casper 2.0, but for the moment, the contract upgrade process can cater to any minor contract maintenance. Here are the most essential points to take away. The new contract function creates a contract package that can be upgraded or versioned by default. Remember that we are versioning the package, not the contract per se. Use new locked contract if you do not want to version your package. The add contract version function helps you add a new contract to the contract package and manages the package version. Finally, you can follow the tutorial for upgrading contracts in the documentation. Here are the links we mentioned previously for Casper types and functions related to contract versioning. The description below will contain the links as well. And here are a few tutorials from the documentation related to upgrading contracts, installing contracts, calling contracts, monitoring and testing. Next, let's dive into a demo and see how contract versioning would look like. Let's review what we have installed previously on the chain with the counter contract. Here we see the account hash, the action thresholds, the associated keys, the main purse, and the named keys. Under the named keys, we see the counter key referencing the contract. We also see the counter access uref and the counter package name we had defined when we created the contract. Also notice that we have a version named key. This will help us keep track of the latest version of the contract package. Let's check the version number. So here we see that our version is 1 at the moment. This means that we haven't yet performed any upgrades. Out of curiosity, let's also check the details of the contract package, which is the container for our contracts. We can do this by querying the counter package name, which is the name we gave our package when we created the contract with new contract. You can see in the response the package access key uref. You can see the contract hash of the contract enabled currently and the latest version of the package, which is 1. Now let's check the contract entry points by querying the counter named key. Here we can see that we have 2 entry points, counter get and counter inc. We also have the named key count, which stores the value of our counter. Let's now check the value we store. It should be 0. As expected, the counter is 0. Now let's increment the counter 4 times by calling the following put deploy. Notice that for the session package name, I specify the counter package name, which is the name of the package I gave when I created a contract. So we will call this function 4 times. So I'll call it 3 more. And now we will get the latest state root hash to see the latest picture of the global state. Now let's check again the value stored in the counter by querying the count named key. As we can see, the parsed value is now 4. Also, if we go to our account on the Casper testnet, we will see that after our deploy, we were able to call the increment function 4 times successfully. So if we go to the raw data, we will see the entry point called was counter inc. Now let's modify the contract and send it to the testnet via deploy. Once we complete this step, we have essentially upgraded our contract. In this demo, we will add a new entry point called counter decrement, which will decrease the count value by 1. We will look briefly at the code. So this is the same contract I have deployed previously with one added entry point called counter decrement. I have kept the counter inc entry point and I have added a new entry point for counter decrement. It simply decrements the value count by 1. Then we have also kept the counter get function. So now that we already have a contract on the chain, we will just add a new version to the contract package by using the add contract version function. We have specified the counter package hash, the counter entry points above, which includes the counter decrement and the counter named keys. And just to double check, the counter package hash, it's the counter package name here. Alright, so now let's build it and send it to the network via put deploy. Here we are sending a new version of the contract to the chain. And meanwhile, we can also check our account status. Let's now get the latest state root hash. Wonderful. So now we see that we have a new entry point for counter decrement in addition to counter get and counter inc. Now let's check the version and package details with the latest state root hash. We can see that the version has increased to 2. Let's now check the package details. So we have here the contract package with 2 versions and 2 different contracts. Now let's exercise the new entry point and check our results. So, as you remember, our count value was 4. Now we called put deploy and we invoked the counter decrement entry point. We will actually call this twice. Now with the latest state root hash, we should check again the value of our count. As expected, our counter was decremented twice, so our value is now 2. Let's double check our count details here. So we have 2 successful calls, which called counter decrement. So, as you see, we have a second version of the contract where we have a new entry point and completely new behavior, and everything works as expected. Thank you for joining me. We have reached the end of our demo.